So, question number 56 is on your screen. The weight of silver displaced by a quantity of electricity which displaces 5600 ml of oxygen at STP will be. So, this question is come from your electrochemistry chapter of your class 12 NCERT. So, now we are moving to the solution part. So, if you see the Faraday's second law, okay. So, what it said, W of W1 by E1 is equal to W2 by E2. So, here W of silver, that is Ag, by E of Ag is equal to W of O2 by E of O2. Now, first let us see the W of Ag. So, W of Ag is given as 108, sorry, we have to find out the W of Ag, okay. And for this one, that is the equivalent weight. So, it is divided by 108, because 108 is divided by n factor will give you the equivalent weight, and for oxygen it is given as 5600 ml. So, this one we have to first convert it into mole. So, how you convert it? 5600 ml divided by 22 by 400. So, it will be end up with 22.400 into 32, okay. So, mole it will be given by weight. So, because mole is equal to given weight divided by molecular weight. So, if I need find out the weight is equal to mole into molecular weight. So, it will give you the mole and it will give you the molecular weight. So, now if you do the multiplication here, you are end up with the answer of 8. Solution of this problem, we are end up with 16, 1, 1, 2, again 'See'. So, end up with 8. So, the weight of O2 it will be coming as 8 gram. So, now just put the value, weight of O2 it will be coming 8 gram, and what is the this one, what is the equivalent weight of O2, that is also 8, right, because O2 it will be coming as 16 divided by 2, this is 8, okay. So, this is the equivalent weight of oxygen. Now, W of Ag, that is weight of silver, is equal to cross multiply, here 1 will be coming. So, 108. So, 108 is the weight of silver, and they ask you the weight of silver here. So, now if you see in the option number 4, that is 108 gram is the correct answer of your question number 56. So, now we are moving to the another question, that is question number 57. So, question number 57 is on your screen. So, which of the following statement is correct for the spontaneous absorption of a gas? So, this question is come from a thermodynamics chapter of a class 11 NCERT. So, now we are moving to the solution part. So, they ask you the spontaneous, okay, and for spontaneous we know delta G should be negative, and what is the formula for delta G is equal to delta H minus T del S. So, if you see the option number 1, delta S is negative, therefore, delta H should be highly positive. Now, if it will be negative, so what will happen? Negative and negative it will be positive here, and delta H they already said positive, means overall term it is we end up with positive, but we require negative. So, option 1 we can neglect it out. Now, see option number 2, what they said, delta S is negative, okay. So, now here again delta S is negative, okay, delta H should be highly negative. Now, if it is negative, so negative what is the end up? You are end up with the positive answer. Now, they are saying delta H should be highly negative, so it is more negative. Now, if it is value is more negative and it will be positive, so your answer will be end up with negative only. Like suppose if I am telling this is the 10 value and this is your 2 value, you are end up with minus 8. Similarly, if it is a highly negative and this terminology is come as positive, so negative and positive will give you a negative and we require delta G is negative. So, option number 2 is the correct answer of your question number 57. So, now we are moving to the next question, that is question number 58. So, question number 58 is in your screen. For the reversible reaction, given the reaction, the equilibrium shift in forward direction. Okay. So, this question is come from your equilibrium chapter of your class 11 NCERT. So, now we are moving to the solution part. So, here that equilibrium is shift forward direction and they gave us heat is released. So, this is the application of Le Chatelier's principle. So, for Le Chatelier's principle we required increase the pressure and your decreasing temperature will favor this forward direction. Okay. Now, they are saying the shift in forward direction. So, if you see you have a high pressure and your temperature should be low. Now, if you see in the option by increasing the concentration, no, this is not the option. By decreasing the pressure, no, we require increasing pressure. So, this is also not the correct answer. By decreasing the concentration, no, this is not. By increasing the pressure, see pressure should be increases and decreasing the temperature. So, this is the correct answer and this is the application of Le Chatelier's principle. Okay. So, option number 4 is the correct answer of your question number 58. So, question number 59 is on your screen. For the reaction, so they given the reaction and they given the value of delta U equal to 2.1 kilocalorie, delta S equal to 20 calorie per Kelvin at 300 Kelvin. Hence, delta G is. So, this question is come from your thermodynamics chapter of your class 11 NCERT. So, now we are moving to the solution part. So, first of all we have to using this formula to calculate delta G. Delta G is equal to delta H minus T del S. Okay. So, this formula we are going to use it here. Now, first let us find out the delta H. How to find out delta H? Delta H equal to delta U plus delta Ng by delta Ng RT. Now, if you see here all are given in kilocalorie form. Okay. So, even in answer also they ask you in kilocalorie. So, here R value we should take it as 2 into 10 to the power minus 3 kilocalorie. Okay. This value we are going to take. Now, for T we have to take it as 398 Kelvin and for delta S equal to 20 calorie per Kelvin. Sorry, that T should be 300, okay, because here it is mentioned as 300 and delta S also 20 calorie per Kelvin is given. So, this value should we have to convert it into kilocalorie. So, 20 into 10 to the power minus 3 kilocalorie per Kelvin. Now, let us solve this problem. Delta U, what is the value of delta? 2.1 kilocalorie. So, 2.1 plus delta Ng. So, delta N for this reaction equal to 2 minus 1, okay, 2 minus 1 that is 1. So, delta N for this is 1. For R again we should take 2 into 10 to the power minus 3, temperature is 300 Kelvin. Now, after solving this part you are obtaining as 3.3 is the value of delta H. Now, substitute delta G value. Delta G is equal to delta H is nothing but 3.3 kilocalorie minus T. What is the value of T here? T is nothing but that is your 300, and delta S is nothing but this one 20 into 10 to the power minus 3. Now, if you solve this one, 3.3 minus 300 into 20 into, sorry, no need of 20 into 20 divided by 1000. Now, cancel it out. So, you have to left it out 3.3 minus 6. So, your answer is coming as minus 2.7. Now, if you see here, this is not possible, this is also not possible. Among this minus should be contained this part, that is minus 2.7, and answer number 2 is the correct answer of your question number 59. So, now we are moving to the next question, that is question number 60. So, question number 60 is on your screen. For a given exothermic reaction, Kp and K dash P are the equilibrium constant at temperatures T1 and T2 respectively. Assuming that heat of a reaction is constant in temperature range between T1 and T2, it is radially observed that. So, now we are moving to the solution part. So, this question is basically come from your equilibrium chapter of your class 11 NCERT, and the formula which we are going to use it here, that is log of K dash P by Kp equal to delta H divided by 2.303 R into T2 minus T1 divided by T2 T1. So, this formula we are going to use it here to solve this problem. Now, if you see, it is an exothermic reaction. Okay. So, for exothermic reaction we have two conditions. The first one is T2 is greater than your T1, and another one, that is delta H is equal to negative. Now, if you see the first thing, okay, that is T2 greater than T1, it means this part, that black shaded part, this value is come as your positive value, and if you see your delta H, this part, rounded part, this value is coming as your negative, and negative and a positive, the resultant will end up with your negative. It means we can write like this, log of K dash P by Kp is equal to negative, or we can write like this, log of K dash P minus log of Kp is equal to negative. Now, the value should get negative when this Kp, that is the log Kp value, it will be greater than your log of K dash P. So, we can write like this, right, log of Kp is greater than your log of K dash P, and if I am removing this log part, we are obtaining Kp is greater than your K dash P, and this one is the answer. Okay. So, if you see your among 4 options, option number 1 where Kp greater than K dash P is the correct answer of your question number 60. So, question number 61 is on your screen. So, which of the following orders of ionic radius is correctly represented? So, students, this question is a bonus question, because whatever answer they are given, this all are in a wrong format. So, in the exams they are given the marks in a form of bonus. So, now see what are the answers should be. So, if you see in the first one, this order is incorrect. See, H minus will come first. Your anionic radius is always be greater than your normal one and your cation. So, this is cation, this is your normal one, and this is your anion. So, here I am writing anion, normal, and your cation. Now, if you see the option number 1, this will be anion is larger, but this should not be there. So, H minus, H and H plus, this is the correct order. Now, if you see for this one also, here O2 minus will come first, then your F minus, because this is the larger anion and it should be S come as Na plus. So, this is also a wrong. Now, if you see for option 2, it will also a wrong. So, it should be O2 minus, F minus and Na plus. Okay. So, this is also a wrong. Now, if you see for this one, here also N3 minus is larger than Mg. For this N3 minus will be greater than your Mg2 plus and your Al3 plus. So, if you see the all options are wrong. So, this is a bonus question. Okay. So, this is a bonus question and you will get the marks. So, question number 61, this is the answer. Now, we are moving to the next question, that is question number 62. So, question number 62 is on your screen. 1.0 gram of magnesium is burnt with 0.56 gram of oxygen in a closed vessel. Which reactant is left in an excess and how much? So, now we are moving to the solution part. So, if you see here, they give you the 1.0 gram of magnesium and it is burnt with 0.56 gram of oxygen. So, what is the reaction here? Like magnesium, when it is react with oxygen, it will give you magnesium oxides. Now, if you balance this equation, 2 Mg and 2 will be here. So, this is the resultant reaction. Okay. So, this is the resultant reaction. So, first we have to convert it into moles. So, if you see number of moles of magnesium is equal to given weight divided by molecular weight. What is the molecular weight of magnesium? That is 24, and this value is approximately come as 0.041 mole. Okay. And if you calculate the moles of oxygen, it will become as 0.56 and 16 into 2, that is 32, and this one is end up with approximately 0.0175. Okay. So, these two values are just an approximate value. In home you just try to calculate this. Okay. So, 0.041 mole and 0.0175. So, I am writing here number of magnesium, it will be coming as 0.041 and oxygen mole it will be end up with 0.0175. Okay. So, now just concentrate on this equation. Okay. So, initially what will happen? So, initially if you see your magnesium concentration, that is 0.041 mole will be there and it will be react with 0.0175 mole, and initially the magnesium oxide concentration is 0. But if you move on to the final concentration, if you see who having the more concentration here, that is your 0.041 magnesium and 0.175 mole, it will be less. So, this oxygen is act as your limiting reagent. So, if you see here like from 0.041 minus 2 into 0.0175, this is the final concentration of your magnesium. And what is the final concentration of oxygen here? It will be again 0. And what is the final concentration of magnesium oxide? It will be 2 into 0.0175. So, if you solve this part 0.041 minus 2 into 0.0175, its results is approximately end up with 0.0066 mole. Okay. So, just try it in your home, how to come, it will be, you will get the answer approximately, okay, 0.0066 mole. We are not required this part. So, which one is excessive amount? That is, your magnesium is present in excessive amount. So, option number 2 and option number 4 we can neglect it out, because oxygen is present in the limiting reagent. Now, this mole we have to convert it into your weight, that is in gram. So, number of moles is equal to given weight divided by molecular weight. So, given weight is equal to number of moles into molecular weight. Okay. So, how much number of moles is there? That is 0.0066 into, what is the molecular weight for magnesium? That is coming as 24. Now, when you solve this part, your answer is approximately end up with 0.16 gram. So, this is nothing but this is the magnesium excess concentration. So, if you see among this option, option number 1 and option number 3 we have to left it out. We have to get the answer, that is option number 1, that is magnesium which is present in excess amount and the concentration is 0.16 gram. So, option number 1 is the correct answer of your question number 62. So, question number 63 is on your screen. The pair of compounds that can exist together is. So, now we are moving to the solution part. If you see here, this one is an oxidizing and reducing agent, here also oxidizing reducing agent, here also oxidizing and reducing agent is present. But if you see in the option number 3, this is also act as a reducing agent and this is also a reducing agent. So, they are saying that the pair of compound that can exist together is. So, these are the reducing agent both, and your option number 3 is the correct answer of your question number 63. So, now we are moving to the next question, that is question number 64. So, question number 64 is on your screen. Be2 plus, that is beryllium 2 plus, is isoelectronic with which of the following ions? So, now we are moving to the solution parts. So, it is a very easy. If you see Be2 plus, so I am first writing the Be, it will be the outer electronic configuration, it is coming as Ns2. Now, if I am taking as Be2 plus, it will attain the noble gas electronic configuration, right? Noble gas electronic configuration. Similarly, if you see Li plus, okay, it is also noble gas electronic configuration, that is I am writing here helium, okay, helium configuration it will attain. Now, lithium, when it will lose one electron, it is also attain the helium electronic configuration. So, if you see option number 2, that is Li plus is the correct answer of your question number 64. So, this is a very easy question and this is coming from the your NCERT syllabus of your class 11 chapter, that is structure of atom. So, this is a very easy question and it is coming from your classification of elements of your class 11 NCERT. So, now we are moving to the next question, that is question number 65. So, question number 65 is on your screen. So, which of the following molecule has the maximum dipole moment? So, now we are moving to the solution part. If you see the options, they ask about the maximum dipole moment. Now, if you see the option number 1, dipole moment is 0. So, this is not our correct option. In methane also, like the structure of methane will be like this, okay. So, you have to draw the arrow from least electronegative to more electronegative. So, see, this is the arrow, this is your arrow and this arrow should be like this, means one is from this side and another's resultant is from this side. So, these two are cancelled with each other. So, here also dipole moment is 0. Now, for ammonia, how is the structure? Your structure is look like this. Now, you have to draw a arrow from least electronegative to more electronegative. So, this is the arrow, this is your arrow. In case of lone pairs, when it will be present, you have to draw the arrow in such a manner that head should be towards the lone pair of electrons. So, your arrow should be like this. Now, see here all are in upward direction. So, your resultant arrow is this one. Now, for NF3, this is your NF3. Now, we know your fluorine will be more electronegative. So, here arrow should be look like this, and for lone pairs we have to write arrow in this manner. Now, if you see here 3 will be there, on this side 1 will be there. So, here the resultant arrow should be like this, okay, means this 3 will be cancel out by this 1, but here is all are end up, okay, all are added up. So, as a result we getting a more dipole moment. So, your option number 3 having the maximum dipole moment, and this is the answer of your question number 65. So, now we are moving to the next question, that is question number 66. So, question number 66 is on your screen. So, which one of the following spaces has a plane triangular shape? So, now we are moving to the solution part. Now, if you see among the options, option number 2, if I draw the structure, it will be look like this, okay, and this is nothing but this is sp2 hybridized, and sp2 hybridized is a plane triangular shape. What is the shape? Shape is plane triangular, okay, it will be looked like this. So, plane triangular. So, here option number 2 is the correct answer of your question number 66. So, this question is come from your chemical bonding chapter, okay, chemical bonding chapter of your class 11 NCERT. So, question number 67 is on your screen. Acidity of diprostic acid in aqueous solution increases in the order. So, now we are moving to the solution part. Now, if you see here, they are given for the oxygen series, that is old style say tipo, okay, this is old style say tipo. So, for answer purpose they are not given as oxygen and polonium. So, only the remaining part, that is sulfur, selenium and tellurium, they are given. Now, if you go down the group, what will happen? Your bond length, that is bond length of H2S, H2Se and H2Te, that is the bond length of H and sulfur, H and Se and H and Te, it will be increases. Now, when this bond length will be increases, your bond strength is automatically decreases. You can compare with this one with a string. If you are taking a long string, so it will be very easy to break this long string, but if you are taking a small string, so it is very tough. That is the thing, if bond length will be increases, your bond strength will be decreases. Your bond strength will be decreases, then bond energy, that is the energy to required to break this bond, it is also decreases, okay. Now, up to here maybe everyone is clear. Now, they are asking about acidity order, which one is more acidic and which one is the least acidic. When it will be acid, it will be compared with by the release of H plus. Now, the compound who release H plus more easily, that compound is more acidic. Now, if you see here down the group, bond length increases, the bond strength decreases, and we require least amount of energy to break this bond. That bond between means hydrogen and that element bond, okay. So, we require least energy. Now, if it is the least energy, then that hydrogen it will be easily released. Now, if you see here, suppose in this part we have to provide 10 Kelvin, 10 calorie, okay, sorry, 10 calorie to break this bond between Te and hydrogen, but for this one we required more energy, because what is the reason? Because here bond energy it will be more. So, for this maybe it is 15 and for this one it will be 20. So, this is just a number, okay, for understanding purpose. So, down the group bond energy will be decreases. When bond energy will be decreases, so it will be very easy to release H plus, right? Means this bond can easily break out, means less amount of energy if I am providing, this H plus will be easily released. As a result acidity increases. So, what is the order we are obtaining here? Acidity order, this is the acidity order, okay. So, this last one is be more acidic. Now, if you see in the option number 1 where this one is more acidic, sorry they are not giving the sign here. So, if you see option number 1 only, here what happened, this sign should be there, okay, just make a correct here, this sign should be there. So, option number 1 is the correct answer of your question number 67. Just again I am repeating here, see down the group bond length increases, if bond length increases then bond strength will be decreases. If bond strength will be decreases, we require least energy to break this bond, it means the bond energy decreases. It means the very easy to release H plus, and the compound who release H plus more easily, that compound is more acidic. So, as a result we are get the order of this one, which is option number 1, and this is the correct answer of your question number 67. Now, we are moving to the next question, that is question number 68. So, question number 68 is on your screen. So, they given two reaction with hydrogen peroxide and they ask you role of hydrogen peroxide in the above reaction is respectively. So, now we are moving to the solution part. Okay. So, if you see in this reaction, so what is the oxidation for ozone? It is 0, and for water this is coming as -2. Now, what will happen here? So, here reduction will taking place. Now, who will do the reduction? That is your hydrogen peroxide. Now, the reagent who do the reaction, that reagent is known as reducing reagent or reducing agent. Okay. So, in first reaction hydrogen peroxide acts as a reducing agent. Now, come to this part. Okay. Now, here it will be coming as 2x minus 2 is equal to 0. So, here it will be coming as x on this side and 2 plus 1. So, here it will be plus 1 and here it will be 0. Now, in this case also the reduction taking place, right. So, who will do this reduction? Your hydrogen peroxide. Means this reagent, that is hydrogen peroxide, will help to take place the reduction process in both the reaction. So, this is also act as a reducing agent for this reaction. Basically hydrogen peroxide is acts as an oxidizing agent, but when it is present with the strong acid, they always behave as a reducing agent. And we saw these two reaction where reduction process it will help by this reducing agent, that is your hydrogen peroxide. Now, if you see your option number 3 reducing in A and B, this is the correct answer of your question number 68.